Now we go for the second application of dimensional analysis that starts like this. To derive the correct relationships between different physical quantities involved in a physical phenomenon. Okay. So how it can be done? For that, I consider an example here, a particular physical phenomenon. Propagation of sound through air. So when the air is considered and the sound is propagating through it, the particles of the air will be getting disturbed by the motion of the wave. So to get the correct equation for velocity of the sound wave, means velocity of the sound wave through air, velocity is taken as v. Now as it propagates, we know that it is making disturbance in the medium. So first of all, you have to analyze the process and come to certain conclusions that on what all factors does that velocity may depend. So when we go for analyzing the procedure, we can find that the speed of that wave will be affected by the density of the medium first of all. So velocity depends on density of air because it is propagating through air. So let me take it as rho as the density of it. And deep analysis, we find that through deep analysis we can find that the speed of propagation depends on elasticity of the medium, elasticity of air. Let me take it as E. So basically, these are the quantities on which the speed of the wave may depend. Now after analyzing all this and taking the quantities on which that may depend, then we go for getting the relationship. So first of all we write V, that's what we want to find, proportional to, depends on density we form, and we don't know how it depends on the density. So let me take it as raised to E. The powers we don't know. Maybe sometimes A equal to 1, but we don't know. Then second step we write V proportional to elasticity. That also we consider a power for it. Another step. Because if you assume the same power here, we are concluding that the powers are same. But that is not true. Okay. So after coming to this stage, next stage is that V, therefore proportional to rho raised to A, E raised to B. And we get an approximate equation here, V equal to a constant of proportionality into rho raised to A, E raised to B. So this is the approximate equation. Let me take it as 1. Now next step is to find the values of A and B. So to find the values of A and B, we use the basic condition for equation in physics, that is homogeneity. Left hand side should be equal to right hand side. Therefore, dimensional formula of the left hand side must be equal to dimensional formula of the right hand side. So at this stage I supply the dimensional formula of each and every quantity. Now dimensional formula of V, you know that m raised to 0, L raised to 1, T raised to minus 1. And there is a problem with this K. We have to assume this constant to be dimensionless for the time being. So this being dimensionless, no dimensional formula, then density, mass by volume, right? So it is m raised to 1, L raised to minus 3, T raised to 0. Okay. Now there is a problem. All raised to A. Then elasticity. Elasticity is having the dimensional formula of pressure. Pressure is force by area. Force by area. So m raised to 1, L raised to minus 1, T raised to minus 2, all raised to B. So by applying dimensional formula, this is what we are getting. Now the next step is to find, distribute this A and B accordingly, and we get, let us say, this much. So m raised to 0, L raised to 1, T raised to minus 1 is equal to m raised to A, L raised to minus 3A, then T raised to 0, that means 1, and here m raised to B, L raised to minus B, T raised to minus 2B. This is what we are getting. Now to proceed with this, let us consider from here m raised to 0, L raised to 1, T raised to minus 1, left hand side will be equal to m raised to A, m raised to B. That means m raised to A plus B, then L raised to minus 3A minus B, then T raised to minus 2B we have. Alright. Now at this stage, we said that, or we know that, according to homogeneity, left hand side must be equal to right hand side. Then the powers of the terms here, powers of like terms on both sides must be equal. Okay? Powers of like terms on both sides must be equal, then only this is correct. So when you say powers of like terms are equal, here it is m raised to A plus B. So I take A plus B equal to power of m on the left hand side 0. Like that, L raised to minus 3A minus B, that is equal to 1. Then third one, minus 2B equal to minus 1. These are the three equations we are getting, and from this we can find A and B. It's very simple. From here, the last one, you get B equal to half. B equal to half. Then take this half and put it into this, you get half. Half plus A equal to 0, therefore A must be equal to minus half. Putting this into this one, we get A equal to minus half. So you got the values of A and B. Now that values into the equation 1, we get V equal to K into, K is there, rho raised to, what is A? Minus half. And what is E raised to? B equal to half. So E raised to half. And therefore, we can have the equation V equal to K into root of E by rho. Now this is the equation for velocity of the sound wave propagated through air or any gaseous medium. And here we get the value of K, not it comes as it is. And if you compare this with the exact equation, the ordinary derived equation for velocity of sound wave, that is found to be equal to root of elasticity by density, it comes. This is the actual equation and this is the dimensionally derived equation. And you can see that same similarity there. Only one problem here. In this one, the value of K will come, and that K we cannot find using the dimensional analysis. We cannot. But we can use some other method, experimental method or whatever it is, to find the value of K. But we are coming to this much close by applying what? Dimensional analysis. Okay? That's all.